All right, thank you everybody for joining us for this program from the Medford Public Library and the Jackson County Master Gardeners Association. My name is Spencer Ellis and I am an adult services librarian here in Medford. Just a quick heads up before we get started, we do ask that everybody stay muted unless you have a question at the end, just so it doesn't interrupt our presenter. The mute button is in the bottom left-hand corner of your screen and it looks like everybody is already muted, so perfect on that front. If you have questions during this presentation, please do type them in the chat at the bottom and we will answer them at the end. If it's super important, like not being able to hear the presenter or something like that, we'll address it sooner. But otherwise, we will answer those questions at the end. You can also unmute yourself and ask questions at the end if you would prefer. With that, I'm going to quickly share the Jackson County Library Services land acknowledgement, and then I will turn it over to our presenter, Susan. So, Jackson County Library Services acknowledges that its libraries are located within the traditional lands of the Cow Creek Band of Umpqua Tribe of Indians and the Modoc Nation, as well as the Shasta, Takelma, and Lotgawa people, whose descendants are now identified as members of the Confederated Tribe of Siletz Indians and the Confederated Tribes of Grand Ronde. We take this moment to recognize the Indigenous people whose traditional lands are where residents of Jackson County live today. JCLS is committed to fostering understanding, deep respect, and honor for Indigenous people, and we encourage you to learn about the land you reside on. For more information, go to jcls.org/land. And then lastly, I have to share that the views and opinions expressed in this program are those of the presenter and do not necessarily reflect the official policy or position of Jackson County Library Services. So with that, we will go ahead and turn it over to our presenter, Susan Koenig.
Well, good afternoon, everyone, and thank you so much for spending your Saturday afternoon with me, part of it at any rate, to hear about fertilizers. I am a Jackson County Master Gardener, and so I am doing this on behalf of the association. At any rate, let me start our talk today with a definition. What is a fertilizer? A fertilizer is a supplement. It supplements the soil's native nutrient supply. And all of those nutrients are essential to good plant growth. And it's important to add fertilizers to your garden when the soil nutrient supply is inadequate, and only when it's inadequate. Vegetables are rapidly growing plants. They're annuals. They germinate and produce fruit all in just a few short months. So they grow very rapidly and they need a lot more nutrients than established plants like perennials or trees. One important thing to know is that your soil contains a certain amount of nutrients without any additions by you. The question is, does it have enough? And what does it have enough of? And what does it lack to produce good garden vegetables? And that's why we're here today, is to find out how to find out what you have and what you don't have. So let's proceed. These are the 4 questions that I get asked most frequently when I'm talking about fertilizers. What type of fertilizer should I use? How much fertilizer should I use? When should I apply it? And how should I apply it? Well, before we get into the specifics of these questions, which is really what today is all about, let me say, I think there are 2 different approaches to fertilizing. The very first is to go down to the store, pick out a fertilizer you want for vegetables, and follow the directions on the package. And the second is to start with a soil test and determine how to fertilize, depending upon the results of the soil test and the recommendations of the soil scientist from the lab that you use to get that soil test. The first method is much easier, and millions of people do it every year. The second method is more work for you, but it is much more tailored to the specific conditions of your soil, and it's going to yield better results. Now, when I go to the doctor every year for a checkup, he orders a battery of tests, diagnostic tests, and then when I'm there, he goes over them with me and he tells me how I should correct any deficiencies that the tests reveal. If you use a soil test to determine how to fertilize, it's the same as, what happens when I go to my doctor. But if you just follow the advice on the fertilizer package, you really are flying blind. You don't know whether what you're doing is appropriate for your soil. And as we're going to see, it may not be good for your soil, and it may also have environmental consequences. If you plan to follow the directions on a bag of chemical fertilizer, you really don't need my help. The first three questions, and possibly the fourth question, is already answered on the back of the bag. And but I'm going to assume that because you're here today, that you really want to consider a better method of figuring out how much fertilizer and what kind of fertilizer. And even if it is going to require a little bit more work on your part. So let's figure out. Let's start out with what the nutrients are that a plant needs in order to grow well. The primary nutrients you can see up here on the screen are nitrogen, phosphorus, and potassium, and they are represented by these symbols right here. These are the nutrients that a plant needs in the highest quantity, and particularly nitrogen. That's going to be number one. The secondary nutrients, sulfur, calcium, and magnesium, those are also needed in, well, less quantity, but they're very important no matter what. Nitrogen is the nutrient that is most likely to be lacking in your soil. Almost everybody needs to add nitrogen at some point, but your soil test is going to tell you that. Nitrogen is very important for plants for a number of reasons. It's critical in a lot of plant processes, but most importantly, it has a prominent role in photosynthesis, which is the plant's process of creating sugars, which is what the plant grows with. So it's essential to growth. So nitrogen is associated with plant growth. Now the next one, phosphorus, is particularly important in the development of roots and also in fruiting. It's important in promoting disease resistance and also in the quality of foliage as well. And then the next one, potassium, it plays a lot of different roles too, but we think of it as being associated with overall plant health. Now, master gardeners have a little shorthand that we use to refer to the functions of these different nutrients. Nitrogen we call up, because how do plants grow? Generally up. So nitrogen is up. Phosphorus we refer to as down, because roots are down in the soil. And potassium we call all around, because it's associated with all around health. Now, I mentioned the three secondary nutrients. Sulfur is used in the formation of amino acids, proteins, and oils, which are all important to plant health and growth. It's also very important to chlorophyll, which is the substance that produces photosynthesis in the plants. Now, calcium plays an extremely important role in plant tissue because it enables plants to grow better. It's a key component of cell walls. It strengthens the cell walls and makes plants be able to stand upright. Magnesium is very important too, and is the powerhouse behind photosynthesis. Without magnesium, chlorophyll can't capture the sun's energy, so it can't make any food for the plant. So you can see that they all have very key functions, and I've only just mentioned a couple. I want to highlight the fact that all of these three, particularly the last two, are very important in enzymes in plants, and plants use enzymes to control a lot of plant processes. So these are all really critical. Now, the last ones down here are called micronutrients, and they're so called because it doesn't take very much of any one of these for a plant to function well. They need minute quantities of these, but that doesn't mean they aren't important. They are extremely important. For example, boron down here, boron is very important in the growing tips of plants. You don't have any boron, your plant doesn't have any boron, and the plant isn't going to grow well. But I wouldn't worry about boron in the Rogue Valley because we generally have plenty, and in some places too much boron, which can be its own kind of problem. Now, all of these nutrients are found in your soil. They just might not be found in sufficient quantities in your soil, or in some cases, they might be too abundant. Both of those conditions can cause problems for plants, and they may affect their growth, they may affect blooming, and they may affect how much fruit they give you. I'm not going to go through all of the micronutrients. I just can't do that. And I don't think it's important. But what I do want you to understand is that all of these things are important for plant growth. So before we actually talk about soil tests, let's talk about a very key component, which is the pH of your soil. And that is something that's going to be registered on your soil test also. pH is a measure of a soil's alkalinity or acidity. If you look at this chart here, you can see that there are numbers down here at the bottom. These numbers represent how acid or how alkaline your soil is. So if you get a soil test and it shows that you have a pH, your soil has a pH of 7, that's neutral. That's right in the middle. Anything above that is going to be alkaline. So up here at the top of the chart, you can see it says between 7 and 7.5 is very slightly alkaline. And the next category is slightly alkaline. And then we go up here to medium and then strongly alkaline. Now, if your pH is in the range of 6.5 to 7, you're going to be very slightly acidic. And you see it gets more acidic as you get lower numbers down here. The other thing that this chart shows you is how well plants can absorb nutrients at different levels of pH. Where the lines are fat, that's where the plant can absorb it the best. So, you look at phosphorus here and you start getting down into medium acidity in your soil, and your plants are not going to be able to absorb phosphorus very well. You see how the line gets skinnier and skinnier over here. So that's what this chart is telling you here. And for vegetables in particular, vegetables, generally speaking, like a pH that's between 6 and 7. So in this area right here, they don't really like it that well. Once it gets above 7, it gets more difficult to grow vegetables. They really like it down here in the 6s and 7s. Now you can amend your soil. If you find out that you have, let's say you have an alkaline soil and you want to grow vegetables, you can amend it to make it more acid. You bring down the pH of the soil by adding something called elemental sulfur. You can get it comes in a bag, you spread it, broadcast it on your soil, and you can get it at just about any store, like any of the lawn and garden stores or at the Grange or any place like that. It's very common, and it's called elemental sulfur. Now, what happens if your soil is too acid? And soil does acidify over time naturally. So it's very possible that your soil can change pH over time and it may get more acid. Maybe it's a little too acid. Now, if you wanted to grow strawberries or blueberries, having really acid soil is not such a bad idea because they like very acid soil, but vegetables, not so much. So in order to make it less acid, to raise the pH, You can add what's called dolomitic lime, and that too is also very commonly available at garden stores. So this chart is available on the internet. You can, take a closer look at it if you want, but you just really need to know that if you're going to grow vegetables, you need to have a pH, generally speaking, in the 6 to 7 range, and that's going to give you a good pH for all of your vegetables. Okay, I want to show you a little bit about what a nutrient deficiency could look like. Of course, there are many possibilities for nutrient deficiencies. As you saw, there's a long list of nutrients. But this one, I'm just going to show you a couple. This one right here, this picture up at the top, the first one, let me see, right here. See how the leaves are all yellow? This is a nitrogen deficiency. What happens is the plant doesn't have enough nitrogen. Maybe, I don't know, you didn't fertilize or something like that. Its lower leaves, its older leaves are going to start turning yellow and they're going to fall off. Because what happens is the plant takes the nitrogen out of these leaves and sends it to the growing tips so it can keep on growing. That's its imperative, to grow, to produce flowers, to produce fruit, and then seeds. All right, so that is very stressful for the plant when it doesn't have enough nitrogen. But this is what it looks like right here. Phosphorus deficiency is going to show up like this. You see how chlorotic these leaves are? Chlorotic or chlorosis means that the leaves yellow, and it means that the plant is losing chlorophyll. So it is losing the ability to photosynthesize and produce nutrients, produce sugars for the plant, the food for the plant. Come down here to potassium, and you're going to start getting a browning and yellowing of the leaves around here. The leaves also tend to look more chlorotic like this. So this is also, of course, not good for the plant. These are stressful events for the plant. However, these are things when they when the soil doesn't have enough of it. However, there's another effect. There are other effects when the soil has too much of a particular nutrient, and that will generally happen if you put too much fertilizer on. So, for example, too much nitrogen on tomatoes or other fruiting crops like eggplants, for example, it can cause them to grow excessive foliage because nitrogen, growth, foliage, okay, and not enough fruit. So it's putting all of its energy into growing vines and leaves, but it's not putting enough into growing fruit. Well, you want tomatoes, right? So be sure not to put too much nitrogen on your tomatoes, and particularly not to put it on at a certain time when it's fruiting. You want to put nitrogen on in the beginning of the season when the plants are growing, right? At any rate, when root crops such as turnips and carrots get too much nitrogen, you're going to have very tiny and sort of unsatisfactory carrots and turnips and root vegetables. So you don't want to put on too much nitrogen, particularly during the growing period. In the beginning, they want some nitrogen. Anyway, if you pour on phosphorus when it's not needed, it can kill off the fungi in the soil, the good fungi, which helps plants and which inhibits the plant's ability to uptake iron and other nutrients. So you see, there is what I would call a dependency between the different nutrients. You've got too much of one nutrient, it can prevent the plant from accessing another nutrient. That happens with zinc and iron, like that. If you have too much of one, the plant really can't take up the other. Now, you don't have to remember all of these dependencies. With an introductory course like this, you're not really going to remember all of it. But what I do want you to remember is that there are dependencies. Okay, and that's what's important, because I think that'll help you to realize that you shouldn't be putting on too much fertilizer. Okay, so let's move along. This is what the soil test looks like that I got. I got this about 2 years ago, last year. I got it last year. And this is a soil test for my vegetable garden. Now, I talked over the results of my test with a soil scientist at the company, and I learned a lot about the condition of my soil and what to do to improve it. So let's look first at the pH. See this number right here? The pH of my soil is 7.2. Ooh, too high for vegetables, a little bit too high. Not terrible, but not really where I want it to be. It should be down in the 6 to 7 range, the 6s. So I just talked about how you add elemental sulfur if you want to lower the pH. Well, that's what I'm doing. So I'm going to do it for 2 years. And then I'm going to take another test and determine whether or not what I've done has actually done the trick, or whether I need to, keep on doing it. Generally speaking, you may need to keep on doing it, but I want to know if it's lowered it. So this fall, I'm going to get another soil test. And the soil scientist I talked to recommended the amount of elemental sulfur that I need to use, that I should broadcast. And that's right here. See this right? Wait a second. I don't know. That's not it. Okay, he recommended it to me, and that's what I used. So I have that somewhere else, I think. So let's look now at this graph up here at the top, the red, green, blue graph. You see right here, these are all of the nutrients that I had in that list. These are all the nutrients that have been tested for. And let's see, over here on the side, it kind of evaluates for me whether it's high, very high, whether it's a medium amount, low or very low. And down here, see, these are the results along this line right here. That's what they're interpreting to tell me whether or not it's, high. Because if, I look at this, I say, well, 124 parts per million. I don't know what that means, but I do know that it's showing that this test for phosphorus shows that I have a very high percentage of phosphorus in my soil. This is a really useful, graph to me. Let's start over here at the left-hand side. Now, organic material is not a nutrient. Organic material is what I call a bank of nutrients, because as it breaks down in your soil, this is like compost, as it breaks down in your soil, and it's those microorganisms that break it down, as it breaks down, it releases nutrients, but it is not itself considered a nutrient. It's a soil conditioner, which is really important. Now, I have 16.4% of my soil is organic material, which makes sense to me because I have just been pouring on the compost. I had very sandy soil, and so the water was draining through it, and so I put a lot of compost on so that it would retain moisture. And this is not a problem to have a very high amount. A more normal amount would be about 5% organic material, but you don't really need to worry if it gets higher than that. It does have a few effects though, and I'm going to show you that. Let's see, right now. The reason why I have a 7.2 pH is because I have such a high organic material content. It will tend to raise your pH of your soil. Okay. Let's see. What else did I want to tell you about this? Okay. The next part of the right is nitrogen. You can see right here. So I have a medium amount of nitrogen in the soil, but the soil scientist thinks that I need to add more nitrogen because plants pull a lot of nitrogen out of the soil. And It also is pretty volatile in the soil. It can wash through the soil. And so you can lose it very easily, and it's drawn upon very heavily. So the chances are pretty good that you're going to have to add nitrogen during the growth period, the heavy growth period in the first half of your vegetable plant's life. And I got a recommendation from them as to how much nitrogen to put on. Down here, it's 1.2 pounds for 1,000 square feet. And it just so happens that my garden is just about 1,000 square feet. So this is what I had to put on once a year. And he was recommending that I put it on in 2 applications. One in the early spring and one kind of in the middle of the year, like in June. Right before the fruiting season, the plants start to grow, flowers and fruit, because they're going to need more nitrogen then. All right, phosphorus. Here, there are 2 methods of, analyzing the phosphorus in the soil. So this reports the results of those 2. And it shows that I have a high amount of phosphorus. I do not need to add any more phosphorus, so I do not need a balanced fertilizer. And this is a really important thing for me to know, because you have too much phosphorus, you can cause problems. All right, potassium is another one here. I have plenty of potassium in my soil. I don't need to add any more potassium. Magnesium is fine. Calcium is fine. Sodium, I'm glad that the sodium is low, because sodium is the basis of salty soil. And you don't want salty soil. You want, so I want to keep this low. Certainly don't need to add anything like that. Sulfur, okay, sulfur is a little low. Now, sulfur, this sulfur right here is a sulfate. This is the nutrient. Elemental sulfur is not a nutrient. It is what acidifies your soil. Sulfate, which is with this chemical composition, is what provides nutrient sulfur to your plants. So they're 2 different things. So I'm putting elemental sulfur and sulfate onto my plants, onto my garden, as well as nitrogen. Now you get down here into the others. I'm not going to go into all of these, but it is a little bit concerning that I have a pretty high amount of boron, because a high amount of boron can inhibit plant growth. So I certainly don't want to do anything to put any more boron on it. And in some areas of the Rogue Valley, we have a lot of boron in the soil and in the water. So, it can really cause problems and hard to get rid of too. Let's see what else we need to talk about. Okay, so the table to the right here shows the cation saturation percent. All of this is about chemistry. Nutrient uptake by plants is all about chemistry. I'm not really going to get into the chemistry. I just want to tell you that this particular graph indicates, for somebody who knows how to read it, it indicates how fertile your soil is. And the readings here show that my soil is pretty fertile. Now you can get an interpretation from the soil scientists that you talk to from the company who did your soil test. And this indicates, it looks kind of funny, the graph. It looks like, well, some of these look pretty low, but those are normal ranges. At any rate, this shows that I have pretty fertile soil. This number down here, the CEC number, also indicates that I have pretty fertile soil. And again, I can give you some kind of an indication. If this actually tells you a lot about what kind of soil, what texture of soil you have. So let's say we saw a 5 here. 5 would be a very low reading, and your soil would not be very fertile. It would be more like beach sand. But the higher you get, the more percentage of, generally speaking, the more percentage of clay you have in your soil. So when you get to 25, that means that you are getting into having clay soil. But before that, you have some clay in your soil, or you may have some clay. But clay is very, very, clay grabs onto nutrients and holds onto nutrients. So that's what makes your soil fertile, is because if there's a lot of clay in it, it's going to be holding a lot of nutrients. My soil has another reason for this high number here, and that is that I have a lot of organic material in my soil. That too has a lot of nutrients in it, the organic material. So that's why I'm getting a high reading here, because my soil is not really all that clay. It does have some clay in it, but it is not as high as this would indicate. You can get an explanation of this from the soil scientists that you talk to when you call up the company and say, I have some questions about my soil test. Can I speak to a soil scientist? And you should make sure that you get a company that's going to say yes. Okay, so what this tells me is I need to add nitrogen, elemental sulfur, and sulfate in order to bring those levels up. But I do not need to add anything else in order to have very fertile soil. So let's go on. Okay, this picture, I just want to show you what happens when excessive amounts of nutrients are poured into the soil. They wash through the soil into the watershed. This is the Gulf of Mexico right here. And what you see here is excess nutrients that have washed down through the Mississippi watershed, and they have polluted the Gulf of Mexico to the point where you see here, these are dead zones. Nothing lives there. There are no fish. There are no plants, water plants. There's nothing there. This area right here is the size of Delaware. So this is what we do not want to do. And that's why we don't want to just pour on the fertilizer. Okay. All right, so let's talk about two different classes of fertilizers. One is organic fertilizer, and the other is a chemical fertilizer. And let's look at how they're different. Organic fertilizers come from natural materials. Some examples are here from manure, cottonseed meal, rock phosphate, fish byproducts, which make fish emulsion, brown limestone, and quite a number of other things, depending upon what nutrients the manufacturer wants to put into that organic fertilizer product. On the other hand, chemical fertilizers are often petroleum-based, and they are high in salts. Remember I said you don't want salty soil? This is one of the problems with chemical fertilizers. You're going to start over time, if you put a lot of chemical fertilizers, you could get very salty soil. And the effect is bad for plants, and it's also very bad for the soil microorganisms. The life of the soil decreases the saltier the soil gets. So some examples of how these are made are from ammonium sulfate, processed urea, potassium chloride. So nutrient availability. Now, the only way that an organic fertilizer is going to become available, the nutrients would be available to plants, is if the fertilizer is broken down by the soil organisms, by a process that you can learn more about, but I don't have time to go into it a lot, but it involves the fungi and the bacteria and all the other soil organisms in your soil, and they have to break it down. And when they do, all of those nutrients become available to the plant's roots, and the plant can take it up through its roots, but not beforehand. And microorganisms are usually the most active when it's in the warmer weather, in the spring, summer, and fall. So that's when an organic fertilizer is going to work. It's not going to work in the winter. Nutrient availability for chemical fertilizers, though, is usually immediate because it does not have to be broken down by the microorganisms in the soil. However, it's very caustic usually, and it can kill the microorganisms in the soil. So you have to be very careful with the amounts that you put on. Now, the nutrient content of an organic fertilizer is going to be much lower, and I'm going to show you how to read that and how to calculate it in a minute. Nutrient content of the chemical fertilizers is going to be much higher, generally speaking, but again, caution, because it can be dangerous to plant roots and it can be dangerous to the microorganisms in the soil if you don't use them properly. So let's go on to the next. Okay, here are two different fertilizers. Now I'm just using these as examples. There are many choices. You can use whichever ones you want. But the one on the left is an organic fertilizer. You can see how it says so up here, organics. On the one, and it has what's called a nutrient analysis down here. All by law, all fertilizers must show you what the analysis is. And what that means is the first number here is the percentage of nitrogen by weight in this bag. So 4% of 4 pounds in this bag is nitrogen. 6% is potassium, is phosphorus, excuse me, is phosphorus. And 3% is potassium, okay, by weight of this. And the same over here. This is a chemical fertilizer, and it's a 5-10-10, so 5% nitrogen, 10% phosphorus, and 10% potassium, okay, by weight. These are guaranteed numbers, and this if you add it all up, it comes out to 13%. So the rest of what's in here are fillers. There are things like sand and other organic material. Over here, it's the same thing. This is 25% of the bag is nutrients. The rest of it is fillers. It makes it a little bit easier for you to spread, spread the fertilizer out. Now, if you're using a chemical fertilizer, this is not the only kind of chemical analysis that you're going to see. There are others that are intended for vegetables also, which are 10-10-10, and some are even 20-20-20, which is a very high, very, very high analysis. Okay, so here are some organic sources of different macronutrients, the primary nutrients. Nitrogen, you see this one right here, the blood meal, it has 12% by weight, and it has no phosphorus and no potassium. This is a good one for me to use because remember, I need nitrogen, but I want to avoid putting on any phosphorus or potassium. So this is a good one for me to use. Feather meal is the same in the analysis here. I could use this one as well. Blood meal is very fast acting though. It will break down a lot faster. And because I'm putting it on in the spring, when my plants are going to start growing, I want to put blood meal on. Feather meal is great for a slow release. It will last over the entire course of the summer. It's going to break down much more slowly. Back guano is also a good source, but I'm not going to use this one because look, it has a fair amount of phosphorus in it here. So I don't really want that. So I'm going to use one of the other of these, and I've chosen blood meal for mine. Now, phosphorus, you can You see here, bone meal, fish bone meal has a 12%. It also gives you a little nitrogen, which is kind of nice because almost everybody needs some nitrogen in their soil. That's a possible one right there. Bird guano, you got 11% here. Okay, and this is percentage by weight. And you got bentonite over here. This is going to give you potassium. And there are a number of other things. Green sand is another one. It's slow release, and it will give you potassium over here. See, one of the good things about organic fertilizers is that you can just put nitrogen on. You can just put potassium on. You don't have to get a fertilizer that has all of them together in it. They are, separated out, which is a really good thing for me particularly. Okay, so you might wonder, well, how do I know how much of this particular product to put on my garden? How do I figure that out? All right, my garden is 1,000 square feet. And my soil test said I needed to add 1.2 pounds of nitrogen for that size of a garden. Now, my nitrogen source is this, which has 12% by weight. The weight on this one is 5 pounds. So, my box of fertilizer, 5 pounds. So the way to calculate that is to take your 12% and make it into a decimal, which is 0.12. Then you multiply it by 5 pounds. In this box, there is 0.6 pounds of nitrogen in this. Less than a pound out of that 5 pounds is nitrogen, okay? Now, how many boxes do I need to put on? Well, you take the amount that you need, 1.2 pounds, and you divide it by how much is going to be in each box. And that tells me that I need 2 boxes of blood meal spread over that 1,000 square feet. And that's how you can tell how much you need to put on. Not too hard. If you're not used to doing math, get your grandchildren or children or your neighbor's children or whatever to help you, because they're more used to doing math than we are. Okay, let's go on to the next one. So how and when do you fertilize vegetables? Well, the very first thing is that you need to water first, because plants can only take up nutrients through their roots when those nutrients are dissolved in water. So the soil has to be wet, or it has to be moist. So that's number one. Water first, fertilize, water again, water it in. One way you can do it is by broadcasting it. That is spreading it evenly across. And that's what farmers do, in their fields. If you have a large garden, it's probably the best way to do it. Maybe even, in your raised beds. This is what I do. I broadcast it. Another way of spreading fertilizer is to band it. Banding is where you spread the fertilizer about 3 inches below the soil surface, about 2 to 3 inches from the plant. So if you have a row of plants, you have a band on either side. A band on either side of the fertilizer. And that allows the plant's roots to grow into the fertilizer, as opposed to putting the fertilizer right on top of it. You can also put it in the planting hole. Let's say you're transplanting vegetables into your garden. You can put it right underneath the planting hole and then cover the planting hole up a little bit with soil. You don't want to put roots right on top of fertilizer, because it can be caustic. Particularly chemical fertilizers can be very caustic to plant roots. It can kill them. Another way to do it is top dressing. You've planted your plants already, or maybe it's the middle of the season. You put the fertilizer around the plants, not right up next to the stem, but out a couple of inches where the roots are, and you dig it in, you scratch it into the soil. Another way is foliar spray. We use this with master gardeners. This picture here is, I think most of these that you're looking at right here are eggplants that we grew a couple of years ago for our spring garden fair. And when we're growing vegetable starts, we always fertilize using a foliar spray. Generally speaking, it's going to be fish emulsion. We have a saying in Master Gardeners, fertilize weekly, W-E-A-K-L-Y, weekly, W-E-E-K-L-Y. So fertilize about a quarter of the recommended dose once a week. And it really gives them a good start because they can absorb some of that nitrogen, particularly through the leaves. All right. And we talked about this. You can do it before you transplant them out. You can do it at planting, or you could do it halfway through the planting season, particularly nitrogen, halfway through the planting season. But you don't want to be fertilizing with nitrogen when the plant is fruiting, because that's when you're going to get into trouble. You give it too much nitrogen and it takes away the energy. It starts growing vines and leaves and things like that. So you don't want to fertilize with nitrogen fertilizer once the plant has started setting fruit. Okay, that's all I have for today, except I want to give you an indication of how you can get some additional material, which will be very important for you. Here are some resources. Now, when you're looking for resources on the internet about gardening, be sure to go to an extension, a university extension source. For example, Oregon State University has an extension office, which Master Gardeners comes under the extension office. If you go to that website, you will see a lot of resources about home gardening. One of the things, this one down here, Oregon State University Extension, you're going to find a list of the soil labs that you could use that would serve Oregon. Now, it's a very long list. And I'll tell you, after going through it, there are only 3 companies. You want a company that does soil tests for Oregon, because we have a particular type of soil, and you want somebody who understands our soil. Anyway, there's 3 of them. And you also want to look very closely and call them up and say, how much does it cost? Generally speaking, they're going to cost somewhere $30 to $50, something like that. I haven't looked at it this year, but that's generally what you're going to find. And you want one that does all of those soil tests I talked about. You want an analysis of your soil for all of the nutrients that plant needs, for the pH, and also for the, well, it's nice to have salinity. You want to make sure that you don't have, too much salt in your soil. And then you want to know about the fertility of the soil. So you need the CEC and the cation exchange. So if you get those kind of tests, you're going to have a really good understanding of your soil. And this is where you find the list of, Okay. Now, how do you collect a soil sample? This is extremely important, and there are a lot of YouTube videos on it. I would go, this one, I just happened to run across this one, University of Arkansas, YouTube video on how to collect a soil sample. It's very important to follow what they say, because you will get an inaccurate soil sample if you just dig a hole and, if you don't do what they say, you're going to get an inaccurate soil sample. So another thing that's important Okay, the very first one up here. This is Colorado State ed.edu. It's their extension. You want to go there and you want to look for their recommendations for adding nutrients based on a soil test. Remember I told you that the soil scientist told me I needed 1.2 pounds of nitrogen? Well, how did he know that? Well, this is the table that's going to tell you. You can look at the values that your soil test produced. You can look them up in this table, and it will tell you how many pounds of that nutrient to put on. Okay, so that's, but I am still recommending that you talk to the soil scientist because they can tell you some fascinating things about your soil. It's just that, you know, over time, you're probably going to want to know how to do it yourself. Go to the Colorado State Extension site and find this table, find these recommendations, print it out, keep it, and that's going to tell you how to interpret that, your soil test, how to determine from that soil test how much of something to put on. And then this is kind of a nice home gardener's guide to soils and fertilizers. This is from OSU also, the EDU site. It's a good general guide. So I would recommend that you take a look at that as well. And now I'm done, and I'd like to answer any questions that you have.
I'm going to give people a little bit of time to type some questions into the chat if they have any. Just while we're waiting for people to type, I have a quick question, which is just, I noticed with the example you gave for organic versus chemical fertilizers, the photos, I think one of them was D&B and the other one didn't have the brand listed. Is there anything that specifically indicates that it's organic versus chemical other than the word organic? Or is it just, if it says organic or all natural, that's generally a good indicator? And if it doesn't say that, it's probably chemical.
Well, you can look on the back
Okay.
of the package, and the back of the package will give you a lot more information. But generally speaking, the chemical fertilizers will have a much higher analysis. Something like a 463 is very likely to be an organic. Okay, something like 5-10-10 or 10-10-10 or 20-20-20 or even higher is definitely not going to be an organic. That is definitely going to be a chemical fertilizer.
Thank you. We got our first question in the chat, which is for veggies grown specifically for their leaves, like spinach or lettuce, should I consistently use a nitrogen heavy fertilizer, or should I also use less and more P and K later in the season?
Well, they do need nitrogen, but I would be careful. I mean, you need to add some nitrogen probably, but get your soil test, talk to your soil scientist, and they do need more nitrogen consistently. But you see, they're going to be also producing flowers and seeds later on. And now you're not so interested in that. You're interested more in the foliage. But yes, you need to remember that they will need some nitrogen as they go along. But you never want to put heavy doses of nitrogen on at any time, really. Does anybody else have, oh, there, it seems like there are 4. You know, let me just tell you, I put my my email address in the chat because sometimes things occur to you later, or you might have a hard time finding one of these resources or something. So you can email me. So take my email if you would like, and you're welcome to email me, and I'd be happy to respond, let you know what I think about something. So have I convinced you all that you need to get soil tests? I hope I have. Well, while we're waiting for more, let me just show you. Here's a product. Fish and guano. It's a liquid. This is what I use for a foliar feed. I use 1/4 of the amount that it says on here to foliar feed small plant starts, if you're starting your own seeds, or even if you get some from the garden store and you're not really quite ready to put them out, use this.
Got another couple questions that have come in. Debbie asked, I have a variety of garden beds. How do I sample for this? So in that case, would you need more than one sample, I guess?
Yeah, well, yes. Well, if they're different. I get a different test for my in-ground garden. That's the 1,000 square foot one I'm talking about there. I also have some raised beds. And because I have different kind of soil in both of them, I definitely get different tests. And you'll need also a different test for your lawn if you want to do your lawn, or for ornamental gardens. On the resource slide, I suggested that you find out how to do soil testing online, because there's some very good videos that tell you how to do that. And so does that answer your question? You do need to get one for every single specific different kind of soil that you have, and specific different use, because when if you have a big ornamental garden, let's say you have a rose garden, you have some areas with lawn or something like that, they will not need the same kind of fertilization at all as your vegetable garden. Your vegetable garden is much more likely to need fertilization than your ornamental garden. And if both of them need it, they might both need very different kinds of, different amounts and different kinds of fertilizer.
Thank you. And then one other question. Nicole asked, what are your thoughts on bokashi composting?
I don't do bokashi. I don't know. That's just not one of my that's not one of my areas of expertise. I wish I could help you, but I can't.
And I thought of another question. So at my house, we recently started our own compost bin. When you do at-home composting, do you generally test the compost itself before adding it, or how does that work?
Do I do what? I'm sorry, I didn't understand.
If you have like your own compost bin, and you plan on adding that to your own garden, how do you determine from a compost bin what the NPK is? Is that a test that you do or something else?
Well, you don't. You don't determine that.
Okay.
Compost is a soil conditioner, and it's a bank of nutrients which will break down slowly over time. But it's very good to add it, not thinking that it's a fertilizer. It's not a fertilizer. It is a bank of nutrients that breaks down slowly over time. And the only way you could determine what the real composition of it is to get it tested. The only reason I would test compost is if you are using a compost from somewhere else, not your own, but somewhere else, and you suspect that it might have a very high concentration of, let's say, a micronutrient, something that you might be a little concerned about. And I actually am a little concerned about the source of my compost, because I have a high boron content in my in-ground garden. And I think the reason for that is my source of compost. So I'm going to stop using that because, as I said, boron, if you have too much boron in your soil, yikes, it is an inhibitor to plant growth. So I make my own compost too. And I think at this point I have changed the soil tilth. That's what compost does, is it changes the texture of your soil and it gives you better tilth. And so I think I've done a lot of that. You saw how much how much organic material I have in my soil, 16.4%. That's a lot. It doesn't have to be that much. So as it breaks down, I add my own compost to the top of my soil and I work it in just a little bit. I don't, dig it way in. And it's good.
All right, any other last minute questions before we end today? I'm thinking no, we've given plenty of time for more typing. All right, I'm not seeing any last questions, so I think we're going to go ahead and stop the recording. And then just a reminder before we do have one last Master Gardener presentation for this spring. It'll be 2 weeks from today, same time, also on Zoom. And that one will be focused on no-dig gardening and spring gardening cleanup. So we hope everybody can join us for that one as well. Have a great rest of your day and happy gardening.